Oh, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. The date for tonight is January 20, 2025, and the time is 23:41. That will be 23:41 minus 12. That's 11:41 p.m. Okay. My topic for this evening will be a long video format topic, and this is a continuation of my long video format topic, analytic geometry. And I am now, or we are now, on lesson number 23. Okay, let's proceed. The title of the subject matter for tonight will be analytic geometry, lesson number 23. And the topic is actually, it will be circle example problem. The last time around, I have given you, or I have discussed the concepts of a circle. And there are two variations of a circle. The first variation is actually a circle with center at 0, 0. And the other variation is a circle with center at hk, meaning it is not at 0, 0, and the radius is r. Okay, let's proceed. Oh, this is the problem. Okay, I will try to read the problem. Find the center and radius of the circle with the given equation. The given equation of that circle is x squared plus y squared plus 8x minus 6y minus 15 equal to 0. Additional thing, sketch the graph. So the problem is asking for the location of the center and the value of the radius. Okay, and we shall sketch the graph of the circle. Okay, let's proceed with the figure. The resulting figure will be this one. Okay, I'll have drawn this one ahead of the solution. Okay, but I don't want to discuss first the figure, because before I could discuss the figure, I must have to bring out the solution. Okay. Before we could draw the figure, we must have to specify the location of the center, and that center is at the location hk, and what will be the radius equal to. Because to draw this figure, we must have to locate for the coordinates of the center, and the coordinates of the center is actually at the location hk, and what will be the corresponding radius. So upon the computation of this one, this is now an easy matter to draw the figure. So let's try to bring out first the solution before we will draw. I will rewrite the given equation, x squared plus y squared plus 8x minus 6y minus 15 equal to 0. For us to determine the location of the center of the circle, we must have to separate the x and y terms, okay? Because we will be going to the direction. The direction of the solution is this one here. X minus h quantity square plus y minus k quantity square equal to r square. This is the direction of where we are going for the solution. Okay? The given equation is actually of the form quadratic equation. So if I will try to rearrange the x term and y term, it will be something like this. X squared, I will write beside it an 8x. Then I will write y squared. I will write beside it the y term minus 6y. And the pure constant term, I will transpose that to the right. So this is now equal to plus 15. To arrive at this equation here, we must have to use the so-called completing squares, and this is now a problem of just algebra, completing squares, because we are supposed to bring out a what they call this binomial expansion, and to get that binomial expansion, we must have to bring out the pure constant term, and for the so-called completing squares, the formula and how to compute for the pure constant term that must be added will be of this form here. Okay? Whatever the coefficient of the x term, we will take 1/2 of it. Okay? Then we'll try to square it, and that will be the added constant for that expression to become a perfect binomial. So for the first one here, for the x term, the coefficient of x is actually 8. So I will take 1/2 of 8. Okay, then I will square that one. What will come out will be 16. For the y term, I will take 1/2 of the coefficient of y. The coefficient of y, I will carry the sign, a minus 6. So a minus 6 over 2 will be a negative 3, and if I will try to square that one, it will be a plus 9. So what will be the significance of this 9 here in the 16? The significance of this 16 here is that if we try to add 16 on the pure constant on the x term, this will be the expression. And if I will try to add 9 to the y term, it will be this expression here. For the right hand side, we have inequality here, right? One of the rules under algebra is that whatever you added to the left, it should be also added to the right for the equality sign to be equal, for the equation to be equal. We add a 16 here, so we will add a plus 16 on the right. We add a plus 9 here, so for the equation to be balanced, we add also a plus 9 on the right. Okay? After the addition of a plus 16 and a plus 9 here, the first one now could be grouped into one group. And this is now factorable to the so-called perfect binomial. The factor form of this is actually an x plus 4 quantity square. This is a binomial expansion. If we try to expand this one, what will come out will be this. So if we try to simplify this one, the simplification will just be simply x plus 4 quantity square. Let's try to check it. If we try to expand this one, the first term will be the square of x, that will be x squared. The middle term will be the product of x times 4 times 2, and that will be 8x. And the last part will be the square of 4, and the square of 4 is 16. So for this expansion, the binomial equivalent of this one will be an x plus 4 quantity square. So that's just pure algebra. For the y term, this expansion is now factorable to the binomial y minus 3 quantity square. Because if we try to expand this one, the square of y will be y squared. The middle term will be a negative 3 times y, which is minus 3 times 2. It will become a negative 6y. And the last part will be the square of negative 3. And the square of a negative number will be a positive number, and that will be plus 9. So meaning to say, this expansion here will be the equivalent of the binomial expansion y minus 3 quantity square. For the right hand side, 15 plus 16 will be 31, plus 9, that will be 40. So the right hand side will be 40. Since we are longing for this form here, this equation here will be, if we try to follow the standard equation of a circle with center at hk, it will be x minus h quantity square plus y minus k quantity square equal to r square. So the only missing thing is the square term on the right hand side. And since the right hand side is not a perfect square, we will just take the square root, then we'll square it. Because if we try to square the square root of 40, it will be 40. So instead of just writing 40, we will take the square root and we will square that one. So this form here now is actually this equation. And actually that equation is actually an equation of a circle with center at HK, and with the value of the radius will be the right hand side. And the right hand side is actually square root of 40. So in here, if we try now to bring out the specification of this resulting equation here, it will be an equation of a circle. The location of the center is actually at negative 4 and 3, and the value of the radius is actually square root of 40, and that will be 6.3 units. This is the location of the circle. I will try to check my camera. Right? So, upon finishing this part of the solution, we bring out the coordinates of the center of the circle. It will be at negative 4 and 3, and the radius is actually 6.3 units. Okay? The computation of this negative 4 and 3 is this one. We'll just equate x minus h equal to x plus 4. So this x here cancel with this. So what will come out will be negative h equal to 4. Then we'll multiply this by negative 1. So h now, a negative will be positive h, and h now will be equal to negative 4. So this negative 4 here actually emanates from this one. For the second coordinate, y minus k is actually y minus 3, and this y here cancel with this. So negative k equal to negative 3. Okay, we'll try to eliminate the negative sign. We multiply both sides by negative 1. Negative k times negative 1 will be positive k, and negative 3 times negative 1 will be a positive 3. So the value of k will be 3. So this 3 here emanates from this one. Okay, like what I said, the center of the circle will be at the location negative 4 and 3, and the radius is square root of 40, which is 6.3 units. So if we now try to bring out the graph of this one, it's an easy matter now. This will be the y-axis, x-axis. The location of the center of the circle is actually at negative 4 and 3. So this is the origin, right? The abscissa of the center of the circle is actually negative 4. Negative 1, negative 2, negative 3, negative 4. So this is negative 4. And the value of the ordinate of the center of the circle is actually positive 3. So with respect to this x-axis here, this is 1, 2, 3. So this is plus 3. So the intersection of negative 4 and positive 3, that will be the location of the center of the circle, and the value is actually 4. Sorry for this one, negative 4 and 3. And to plot the circle, we should have a compass over here. 6.3, this is 6.3. This is 6.3. This is 6.3. This is 6.3. So if we try to interconnect this one, what comes out is the given circle, and the equation of that circle is actually x squared plus y squared plus 8x rather, minus 6y minus 15 equal to 0. And the value of the radius is actually 6.3 units. This is the radius of the circle. Okay, and the value is actually 6.3 units. Okay, that's it, guys. The problem that falls under the study of circle is an easy one if you know how to complete squares, and that is just a part of algebra. Okay, for those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJ.Reyes. If you want to share it, please click share. For those who do not know that my channel contains long video format topics on differential calculus, integral, differential equation, advanced math, DC circuit, AC circuit, analytic geometry, trigonometry, and algebra, it's 10 subjects already. So for those of you who are planning to take up engineering, you can watch my channel if you would like to learn those kind of mathematics. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes, and one thing more, my short videos contains many variations. It involves mathematics and some electronic things. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.